Okay, hello everyone. Can you see my screen?
No yet. We are waiting your presentation. Yes, it's okay.
Okay, so let's go back. So I am Sergey Sushko, and with my colleague Alexander Timoris, we would like to introduce our report, which is related to smart grids and namely remote voltage monitoring for smart grid. This is a first report from my research. And some first results I would like to show you. First, as you know, we have big issues with electricity grid in Ukraine. It was mentioned several times before me, so I will not emphasize it. So, as you know, we have some shutdowns, power lost, and so on in the big territory of Ukraine. And what can we do with it? Actually, there are several possibilities which we can provide. And first of all, we need to know in every point of electricity grid, does it available or not? Is it available or not? And also, if some parts of electric grid is use some accumulators as additional power source. So also it needs to be known which reserve we have to power. And another one, we need to use it and to monitor it. So in any case, it's like a flexible system, and every point should be known inside it. So if power is lost, how we can survive, which resource we have, and how we can split between the users. For example, on the picture you can see quite small application. It's from a power station, which can provide quite simple but required information. A load percent and some photovoltaic input. It can use some solar panels, and grid which is off for now, and also power consumption of that home or utility or whatever. It's a domestic system, but in theory it can be extended on like local districts or regions or some factory and some other purposes. Recently, in previous year, it raised some new network which called smart grid. Actually, this is electric grid with some extensions, which includes monitoring, management, switching, and some more efficient usage of electricity. Also, I faced several papers which provide some results which show us that in some cases, usage of smart grid instead of regular grid, it can be 10 or 20% of electric saving by switching between different consumptions and generators. So this is for peaceful time. Yeah, during the war we have another issue. Then everything can be cut it off from national grid, and in such case, smart grid on local place, or maybe not local, with some object on it. For example, it can be some civil infrastructure, it can be some industrial factory, also it can be some military unit which has different troops and electric supply of it. So actually everything of it could be combined under the smart grid technology. And what is my objective of my research? It's the goal of the project is the discovery of existing methods, tools and technologies which can be used to create and manage local electricity grid for civil, industrial and military usage. The final target is an obtaining of knowledge and experience which can be used to create a particular local electricity grid with provided requirements and limitations. And this is like global goal, and current report is related to my task. It's of the project is creation of simple test bench, which will allow to measure, transfer, store, and monitor voltage value of remote accumulator during the discharge cycle. So what it's about? This is about a situation. Then we have accumulator and its charge discharge, and we can monitor its time when we need it. So next, you can see on the picture that it's like what I reproduced it. So on left side, we have some server which can collect data and also provide it to the user which one wants to review it. From right side, it's some voltage meters. For the test, it was only one, but it can be scaled and some very wide range. So the target of it is to measure some voltage on accumulator, or in my case, on the small battery which powers the voltage meter itself, and send the data to the server. And user can monitor the data with some plot, as you can see, or to see some local current values of voltage. So it's not some very specific hardware to user, it's just HTTP protocol, and you can see it with a simple browser, no extra tools are required. So quite a simple test bench I wanted to reproduce, and I set some requirements because just for the very first test, I need only proof of concept, and it should work, but not to provide some comprehensive functionality. And because of it, it should be cheap and has small size and power consumption, and easy to install and easy to use, actually. So, and everything it needs to have some communications interfaces just to provide the data on the server. So in my case, it was a microcontroller board, I'll show you later. And if to go next, we can see that this is data server. It's small board. It's, if you know Raspberry Pi, it's Orange Pi, but 0. So it's even smaller than a regular Raspberry Pi. So it's quite low in parameters, in hardware, but it's still enough to be the server for such purpose. If we go next to control voltage model, it's not only battery, it also has some microcontroller unit and has accumulator which is powered and charged when it's not charged fully, and some extra tools to provide its work. So if you see the structure of the control voltage module, you can see that it has some battery, some external voltage power, and some module which charges battery and discharge when it's required, and also some module which can measure voltage to see directly 5 volts signal and make some diagnostics to see is it okay with it or not. And also it has some Wi-Fi module and with antenna and can provide data in the to the server. So for CVM, it looks like this one. So actually that blue board, it's the main MCU and ADC on it with Wi-Fi, of course. And this is green cylinder is the accumulator, which is inside. It's not so visible from top. And also it has some switch with voltage, so you can see the voltage itself on the board. It's not required any time to see on the server. Okay, so also just to make a proof of possibility to transfer voltage values, it was an idea to use IoT existing infrastructure, technologies, software, and so on. And actually, all hardware was chosen to support it. It's okay for it. And also, software needs to be very known because some very cool but very complicated software can be hard to install and configure. So in my case, I took some Node-RED and Mosquito Broker, like a couple of IoT holding data inside it. And for CVM, it's quite small program which measures voltage and just transfers it to the server when it's available. So actually that test bench, I verified many days. And then was it we had electricity. I didn't have blackout for that day, so I just simulated turn it off, and just to verify it works okay, I tried to discharge the accumulator and then charge it back again. So as you can see, the uplifting lines, it's charging, and for left side, it's voltage of it, and lines down is then it's discharging. So you can see some particular voltage in particular moment. And actually, I did it for every second, so it took a lot of data. And in my next task, I will be increase the time of response because it's not so required. And as you can see, it's something about 24 hours it holds the charge, and about 11 hours is required to charge it back, almost from zero. So in particular cases, I think it will be good enough, but of course it requires some improvements. And next, also there is some real-time indicator which can show you exact voltage for that moment. So it doesn't have memory, but for particular cases, then you have several voltage sensor. You can put it in one line and easily to see is it any issues inside it or everything is okay for it. So in my investigation, I just made sure that IoT technologies and quite cheap hardware can be used for to measure voltage and transfer and show it. And actually, it's very first my results. So I didn't compare it with something else. Of course, I need to extend it because it's very simple for particular usage. And for my next task, I can see that several things can be done. It's refresh time, of course, must be increased. Yeah, reduce it. It's wrong. It should be increased. And microcontroller can go to deep sleep mode. It's also very important because it will not provide almost no power between the measurements. And also some extension like several control voltage models and some like alert if some battery can be drain low. So it can be something in format to the user or users. So actually it's all what I wanted to tell you. So thank you very much for your attention, and please, I'm ready for your questions.
Thank you for your presentation. Do you have any questions to speaker? To Sergey, please.
I have a little one. Maybe I have missed.
Yes, please. Taras, please.
Yeah. Other solutions for voltage monitoring. Maybe I have missed something. Can you compare your solution to an existing solutions?
Yeah, it's a really good question. Maybe it's you was referencing my paper because I had that question. So at that moment, I didn't do it. So my task was like proof of concept. So is it possible to do something before we will compare it or make some big system to make sure about its efficiency? So not yet. And the really big issue is that actually there are a lot of such tools and devices. For example, you can connect, if you have a car, you can connect your battery on the car with specific device, and it will put via Bluetooth interface on your phone every voltage, every change in your car's accumulator. So it's kind of something like that with some status and so on, so on. So I understand that I need to compare it with something, but for the first glance, it seems like so many different technologies with so different purpose and some limitations because, for example, Bluetooth is quite short distance. So it will be a good challenge for me to choose particular hardware and technology which can use a very similar approach as I'm using. But still, thank you very much for your question.
Yeah, thank you.
One more questions, please.
Yes, if it's possible. Sergey, it's pleasure to see you and hear you, and thank you for this interesting and very relevant and actual report. And actually, this topic is too interesting and too important for the moment. And the question is, did you consider it the use of laptops accumulators to allow the autonomous power supply? And it's not only the question, it's like suggestion for everyone to consider the secondary goods market, because in Ukraine currently this possibility is widely available for bulk ordering with price in 10 times less than the price of the new power sources, but at the same time the quality is the original quality, and it allows to use too efficient accumulation of the electricity, and actually it provides an ability to add such smart monitoring to such devices, especially in tasks of balancing of the batteries. So it's on the one hand it's a question, in another hand it's a suggestion. Well, thank you.
Okay, thank you too. So you, as I understand, you was talking about usage accumulators, which still good enough to use in such reserve systems, right?
I'm talking about the possibility of using secondary goods market to build and to construct the bulk accumulators with properties better than some acid accumulators, and price maybe in 10 times less. And for such solutions, the balancing of batteries and monitoring of voltage is two relevant things, and because of that, it's possible to combine the proposed ideas with really cheap and available power sources to ensure the possibility of accumulating of the autonomous energy and then supplying for some home usage and autonomous sources with possibility of providing of few, maybe from 1 to 10 kilowatts before the next charging.
Okay, thank you for the idea. It's everything is good which can make better our electric supply. So actually main idea of the next researches was to use that control voltage models for batteries, not like for default accumulator. It can be bigger battery, some reserve, like lithium, some acid or whatever. But if we can build some quite big amount of power with affordable price, it's every time it's okay, I think.
Okay, thank you, and hope to see your next publications and wait for it.
Okay, thank you very much.
One more questions, please. No one. We have time, so I would like to propose you to take into account in your approaches to take into account the specific characteristics and the characteristics of the accumulator. As the efficiency of accumulator significantly change with temperature, and when the temperature higher or temperature lower, some limits the efficiency significantly decrease. And the using of any accumulator out these bands, it's not, it's a problem. And how to take into account these specific parameters, not only temperature, but also the speed of charging, discharging of accumulator, the restriction of this speed, and the level of energy, the low level of energy stored in accumulator. These three parameters is very important in order to correctly using the facilities of the batteries. Thank you.
Okay, thank you too.
Mm-hmm. Thank you very much, and we will.
By the way, I can see one user has some question, I guess. Leonid just raised his hand.
Yes, please. Thank you for your presentation. Thank you for your presentation, Sergey. I have some small question regarding the voltage that I saw on the some screen. I saw that maximum voltage on your graph it was 4.2 volts, and this means that the accumulator was lithium because for example, lithium from phosphate, it is lower than such voltage. And based on this, I have a question. Did you try to combine several types of accumulators? For example, lithium ferrum phosphates and lithions and or nitrium monochromes?
No, it was not scope of my research. And about the range, I just put it in. I configure it that it's like low and high range. So actually, it was between it. Yeah. So actually, can be scaled for everything or just to be automated. So I put it in some preset because I know where it can be. So in most cases, then the parameter can vary in very big range. It's better to use it like automation, auto setup. So this way. And yeah, about different types, I didn't use it. So just use available for me and just so its behavior and load and discharge.
One more question about backward connection to. Do you have any backward connection from the application to or from measurement system to device that is measuring the voltage?
Could you please explain what do you mean?
For example, you have some glitch on the device and you are remotely working with this device. You want to reload it. Do you have such possibility?
Okay, good question, really, because yeah. So in such configuration, device just ping the server with voltage value. If for some reason device will, for example, turn it off, the server will remember the last values. And for such cases, then it's something wrong with software, for example. It's better to have some watchdog timer which can see is it okay or not with the hardware. It's a good question. And another topic is that in my next approach, which I wanted to use, is just some deep sleep mode. So the hardware will just awake, make measurements, send it to the server, make sure that it passed to the server, and then sleep back. So in that case, it's mostly offline, and it just need to wake up in the timer which was set by deep sleep mode.
So you're not wanted to have some requests from the server that consumes metrics and device itself.
Yeah, I don't want it, but there is several possibilities. For example, if it's some very important voltage is measured, for example, some critical infrastructure or some whatever, what is very important, probably it's it's necessary to have a moment when power is off. And in such case, what I use, I can do it. So it's not provided on my pictures, but also I have like 5 voltage level. So if it's 0, I know that external power is off. And in that case, I can inform the server that I don't have electricity. And it's okay for this. But in case then I sleep, for example, for 10 minutes, and in this time I will have power off, I don't see possibility how to wake up the voltage meter and to send the data. So it's like some drawback of such approach.
And one more question regarding the channel of scientists.
Leonid, sorry, we have no time in order to continue our work,
Okay.
And we see later at 4 past meridian.
Thank you for answers.
Okay, thank you too.
Thank you.